Okay, guys, so let's start today's topic. We'll be looking at one is CNN, okay? It stands for Convolutional Neural Networks, okay? And inside CNN, we'll be looking at filters, right? And then we will be looking at sides, and then we'll be looking at padding, okay? So these two we will be covered if time permits, but till filter I will try to cover it completely. Okay. So before starting on the CNN, the first question raised is that why CNN, right? So I hope you guys be aware about deep neural networks, right? So let's take a little um, overview on um, what are they and how we look at them. Okay, so let's take an example. Okay, let's the example is I love football. Okay, so generally when we talk about deep neural networks, right? Deep neural networks. Generally, to let's say I have to process this sentence, right? Now what I do initially was I create a vector. So for love, for football, I create a vector, right? So let's say I create a vector of size 5 or let's say 4. Okay. So I have one, two, three, four-dimensional size and the values they can be any numeric value inside these vector, numerical values, right? Now, the thing is that when we build a neural network for them, so generally how we do, we create a input layer, okay? So for three-dimensional, I have three as an input layer, right? Then let's say for next layer, I define three more um, nodes inside it, and then this goes like this, right? So I hope everyone of you are aware about it, right? Let's say for the last layer is my output layer. Okay. Now in this particular example, we are seeing that for this individual sentence, I love football, right? I just need a three-dimensional input. Okay. So what I mean to say is, for example, a I have number of sentences, like say sentence one, right? Sentence two, sentence three. So all of my sentence would be of dimension four, right? So this would be maybe one, two, three, four-dimensional vector. Then again, I have a four-dimensional vector, right? And again, I have a four-dimensional vector. So for each sentence, I am getting a four-dimensional vector. Now, for these tasks, we are taking four-dimensional vector. But when we talk about images, right? Now, let's come to image. How we do things in image. Now, when let's say take an example of an image, um, we will be having this as an image, right? And all of us know that in general, for example, let's say I click a image, my pixel would be very like let's say if when we click a image, it is a 640 by 640 pixel image. And if we talk about the depth, then it would be a three-dimensional depth, right? So for a single example of mine, I am taking that many number of values, right? So this would be 640 by 640 by 3. This is my for a single input, right? Now this value is very huge. Okay. So if I like just approximate this, this would be let's say 10 to the power 3 multiplied by 10 to the power 3 multiplied by 3. So this would give me 3 into 10 to the power 6, right? So this is a very huge input. And if I feed this input to my neural networks directly, it would be very hard for me, right? Not in the hard, I mean, I can give it as an input, right? But the thing is that the complexity of my neural network becomes very high. And then again, I have to define some nodes here, right? And then again to define some nodes and this. So this processing time, right? I hope you are getting what I'm trying to say. The processing time of my complete process, right? So my processing time of doing the computation, right? It increases a lot, right? So to handle these scenarios, like how can I handle my images? There is one concept that we comes in picture, which is known as CNN. Okay, so instead of defining the complete input as my inside my input channel, I will be creating some convolutional layer. So, for example, I will be doing, I will be creating a convolutional convolutional layer 1, then I'll be sending it to convolutional layer 2, then to convolutional layer 3, and then finally I will be sending it to my deep neural networks. Okay, so by this point, I have only the important information about my image, and then I will pass it to my deep neural networks, and they will send me an output about regarding that image. Okay, and we will be seeing one example of this soon, right? So let's take an example here, right? Now, um, here comes what filters are. Okay, so filters are just one individual initial multiplication that we did on our set. So for example, let's say I take a image input as, let's say I have an image of this is a 3 by 4 metric. Okay. So just to make things a little clearer for you guys, we will be taking a smaller set. So in general, in it is just a normal case, but in general, these are like very high dimensional, like 300 by 300 or 500 by 500, right? So for this example only, we'll be taking a 3 by 4 dimensional image. And this is just a single image. So single, I mean to say single channel. It's not a 3D image, right? In general, we have three-dimensional images, right? So just to share you guys what how filter works. Filter are generally a matrix only, which is of any shape, right? And once they multiplied by my input, it will generate me some output. Okay. Now let's take an example here, right? Now let me show you how it works. Okay. So for example, this is your filter, right? A 3 by 3 filter you are taking, right? Now, how you do, you multiply by your 3 by 3 filter by this, sorry. A 3 by 3 filter will be multiplied over an input of this, okay? So 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, okay? Now, once this multiplied by this filter, it will generate a single output here, right? So the value will get in output as here, one value. Now, next time the filter of yours will be put to the next value of a 3 by 3 value, and it will be multiplied and it will be get into this. So this is the output that you get. Okay. So in general, if I just remove this thing, this is the output you will get. A matrix. Okay. You will get a matrix of 1 by 2, right? Now, this is the process. So, if I talk about in just an overview of it, this becomes your one convolutional layer. Okay. So you can see the input size that was initially a 3 by 4, now it reduces to 1 by 2, right? Now, our question, the next question we have is that, okay, we do this, it's good, right? But why? I mean, there will be like initially we may have lose some information, right? So, initially, what happened was the researchers looked into it, and these filters, right? The filters are very important here. These filters are created to get the information from these images, from these images, right? So, for example, you have some input image, right? And you put this filter on that image, okay? Now, once you put that image and put it as a output to it, this particular output, the metrics that you get here, right? It contains only the information. Now, when I talk about information, it can be anything. It may be your vertical edges, right? Maybe the object that is there inside the image, you are capturing the vertical images. Or maybe you are capturing the horizontal images, right? Now let's move forward. We will be looking all this in a coding part as well, right? So that time it would be much more clearer. Now there are few filters that researchers already researched and get to know. Okay, if I apply this filter to my this image, this will be the information that I will gain. So few of the filters, like for example, if let's say you want to find the vertical images, right? So there is a 3 by 3 filter which will help you so to get a vertical image from any image. If you have any image, you can just have to multiply this filter and you will get the vertical images. We'll be looking at it. Just give me some time. In the coding section, we will be looking at it. Another filter that we will be having is the horizontal filter, right? So the horizontal filter will give you the horizontal images if there are any. So when I mean to say horizontal images or vertical images, they generally refer to the object that we have inside the image. So for example, so let me mention what the horizontal is. So if you want to get a horizontal uh, values, you just have to multiply your image with this particular filter. So when we talk about the when we talk about what I say, the horizontal and vertical. So let's say this is your image, right? And there is some object inside it. So your vertical would be these verticals line, okay, that are there, and your horizontal would be these horizontal lines that are there in your image, okay. So we have different kind of scenarios. Similarly, we have a filter which was named as, let me name it here. It is called as, the name is um, Sobel filter. Okay. So what this filter is, let me write it down. Okay. So the Sobel filter is 1, 2, 1, 0, 0, 0, -1, -2, -1. Okay. So this is called as Sobel filter. And how it works is, so basically, uh, let's take an example. Uh, Once you have an image, okay, this would be an image, and this is some object inside this image. So when you apply a Sobel filter to this image, okay, as an output, you will get the boundary. So you will be able to detect what the object is inside the image. So you can directly take this image out, take this object out. So in computer vision, generally we work on the object which is present inside the image. So if you apply a Sobel filter to the image, you can remove the background which was there, okay, and you only get the object from that image, okay. So this is how filters are useful, and we will be extracting only the information. So this is just the information that we will get from the image, right? So, as we were discussing previously, where we were looking at it, like so this information that we get here, right? This is what information we will be seeing here, right? So this is what that information is. Okay. Now let's move forward to our second part, where that is stride. Now, strides are nothing. They are just a way how we are processing our image further. So for example, let's say I take one image. Okay. Now let's say I take this as an input. Okay. Let's take a bigger input this time. One, two, three, four. So 4 by 4 input, right? And I take a filter of, let's say, a 2 by 2 filter this time, right? Now, when I'm going with this, right? When I'm multiplying my 2 by 2 filter with this, right? So how many strides I am giving for my next iteration, for my next calculation, right? So as we see in the previous example, the stride was 1. Now in this example, we will be taking a stride of 2. So let's say I mention a stride of 2. Now you get output of this here, right? And this is your output. Now again, this stride would be here, right? Because now you are giving it a two stride, 1 and 2. This will be your output. Then again, vertically also you are taking a stride of 2. Now this would be your multiplication, right? This will get an output. Similarly, this here also you will get as an output, right? Sorry, this is your filter, right? This would be your output. Okay. So let me erase this thing, this part. Okay. These are your filters only. Okay. And when you multiply it, this would become your output. So these will be your output, right? Now let's move forward to our third part, um, which is uh, nothing but padding, right? So what are paddings? Now let's take an example. Let's say this is your image. Okay, you will be having a 4 by 4 image. Now, if you see when we are multiplying it by a filter, right? So for example, let's say I have a 4 by 4 image. I multiplied it with a filter of 2 by 2, and I'm getting a value out here, right? It can be any value. Okay. Now the problem is that isn't it we are giving more importance to these values that are there in center of my image, right? So for example, when I'm multiplying this particular filter, right? When I multiply this filter to this, so for example, I multiplied it with this, right? Then I multiplied it with this. Then I multiplied it with this, right? So these cells that are there in between, they are coming as 2 times or maybe 3 times. But my outer cells, this part, right? They are coming just once, right? So the importance that we are giving to the outer edges, outer part, right, of my image is very less. Now, this is the reason why padding comes in picture, right? So what and how padding work is, let me just undo this thing. Okay. So how padding helps you is that they will provide you another part in your image. So let me switch my pen to the previous one. This particular image will get a padding of, let's say, you add a one padding to it. Okay. So now you are adding a value to the outermost part of it. Okay. So let's say you add a padding of 1. So here you are just mentioning a 0, 0, 0, 0, 0, 0, 0, 0, 0. So this way you are just increasing the outer area so that once your filter is getting multiplied, right? So it gets multiplied to this section. Again, it will multiply to this section, right? Now these sections that are there inside your image as well, they get the importance as well, which initially was not we were doing, right? So maybe there is some image of yours, right? So for example, you take an image, right? And let's take an image, okay? Uh, this is the image, okay? And your object is somewhere here, right? Now, initially, if you are not providing the padding to it, right? The importance was in this section, right? So once you put any padding to it, the importance of yours will come to this also. I hope you are getting my point, right? So this is the reason why we include padding to our image set. Okay, so I hope now it's been clear to you guys, a better clear picture of all these points that we initially discussed, right? We started with CNN, why we use CNN, right? When we have deep neural networks, exactly right. And then we come to the understanding of the implementation of CNN, then filters, why we use them, then strides, then paddings, right? Now let's get to the coding part. Let me show you how in general filter applies to the images. Okay, and I hope like you will understand it better from there. So I hope this is visible to you guys, right? Let me increase it a bit so that it's easily visible. So this is a Colab notebook, okay, and I will be doing implementing a Sobel filter that I discussed with you guys, okay, and I will be putting it over my image, over my input image, right? So you can see here, right? So let me upload a image, okay, and so let's upload this image, okay, and let's run this file. So here you will see it's in running phase, and once it's done, you can see here you this is the original image that we provided, right? Now this is the grayscale image. So a grayscale image is that we converted the complete image to a grayscale image. Okay. How we did it? That how we did this? We take the average, a mean of my different dimensions, right? And then I save it inside my image. Now to detect the edges, what I did, I simply created two filters, Sobel X and Sobel Y, right? And then I multiplied my X and my multiplied by Y. Okay, I hope you are getting this part. With the image, I'm multiplying my individual NumPy arrays, and this is what, so it returns me a ages part, ages as in like the detection that it found. And this is the age detection that is generally a final. So now I can work around this image only. I know that, okay, these are my images, this white, the white part, right? Where the intensity of my pixel is white, right? So I can work around this image only and I can get the more feature importance out of this, right? So because the feature array, right, the array that is extracted from this is very useful. Now, when I feed this individual thing to my neural network, it will give me much better output because these are the important things that I get from this individual image, right? So this is all. This is all for today that we were looking at. I hope you learn few things here. So looking forward to for our next coming class. Thank you so much. Thank you for your time.